Welcome everyone to lesson number 4, Solving Quadratics Part 2. Part 1 we've looked at general factoring. Part 2 is going to look at a method called the Berry method factoring. And that takes place when we have an a value that is not equal to 1 and we can't factor that a value out of everything. Remember last lesson we saw that we could maybe factor out from every term. We're going to have situations occur where that's not going to happen. In fact, a lot of times it won't happen. So we're going to use this Berry method instead. So you might want to write these down right now if you want to pause the video and write them before I go over them. If you memorize these as best as you can, or keep them nearby while you're doing your problems, these are actually some pretty straightforward directions, very easy to do, and it's going to make factoring a lot easier than the old-fashioned guess and check method that I'm not even going to bother showing you. Okay, so step 1, we're going to multiply the a and c terms. We'll call this c prime, and we're going to rewrite the quadratic as x squared plus bx plus c prime. Notice how our a term disappeared and our c term is now c prime, the product of a and c. Step 2, we're going to factor this new quadratic as usual, so just like we did in that general factoring lesson. Step 3, we'll divide each factor by the original a value and reduce. We want to make sure that we reduce, okay, pretty important. And then step 4, move the denominator value to in front of each corresponding x. That doesn't make the most sense right now, but when we actually do it out, you're going to be like, okay, I get what you're doing here. And then finally, once factored, we're going to solve each piece individually. This is just like what we did at the end of every problem last time. Once it's in factored form, set it equal to 0 and solve. We want to figure out what the roots, solutions, are to these problems. Alright, so let's do an example of this. Right now this is still showing, so if you haven't written it down, we're still going to be able to reference it for this problem. Our first step tells us to multiply our a and c term, and we're going to rewrite without that a term. So I'm going to start off x squared minus 7x. And if I multiply 3 and negative 20, we get negative 60. Now, step 2 tells us to factor this quadratic. Alright, so I need two numbers that multiply to negative 60 and add to negative 7. Well, one of them has to be positive and one negative. The larger will be negative. How about 12 and 5? Step 3 says divide each factor by the original a value. Our a value here was 3. So I'm going to divide the 3 and the 12, I'm sorry, the 5 and the 12 by 3. And then if we can reduce, we're going to. This will not reduce. This, however, will reduce to 4 and 1. Then step 4 says move the denominator value to in front of each corresponding x. So this 3 is going to move right in front, and this will become 3x plus 5. So we no longer have a fraction there. This 1 technically will move up in front too, but we don't have to write it, so it will just look like x minus 4. Remember that reduced to minus 4 equals 0. And then just like the last problem, once it's factored, we will solve each piece individually. So we just did the Berry method right here. Right, that's all Berry method, different way of factoring. Now comes the solution part. Okay, so I took each piece, set them equal to 0, and then we'll just solve each of those. Subtract 5 from both sides, and then divide by 3. We get x equals negative 5 over 3 for our first solution. And on the second one, we'll just add 4 to both sides, and that will give us x equals 4. So here are our two solutions. Okay, that's the Berry method, factoring and solving. Right, Berry method is all right here. We followed these steps pretty clearly. If you need to rewind this video and look back to see how any of that was done, please do. Okay, we're going to move on to another example right now. Those directions aren't going to be visible though, so hopefully you have them written down. Alright, we want to solve 2x squared minus 15x plus 18 equals 0. First step of Berry method says multiply a and c and rewrite without the a term. So let's start rewriting without that a term. We're going to multiply 2 times 18, which gives us 36. Alright, now we need two numbers that multiply to 36 and add to 15. However, we know that they're both going to be negative numbers because this is positive and that's negative. So I'm thinking, how about 3 and 12. Okay, step 3 says divide each factor by the original a value. So our original a value is 2, so I'm going to divide here and here by 2, and then we'll reduce. That will not reduce. This will reduce to 6 and 1. Step 4 says move that denominator to the front. So 2x minus 3. This doesn't really have to move because it's a 1. It's not going to make a difference. That gives us x minus 6. And finally, we're going to take each of those pieces, set it equal to 0. I'll start off by adding 3 to both sides and then dividing by 2. We'll get x equals 3 over 2 for our first answer, and our second we'll just add 6 and get positive 6. Okay, Berry method factoring. I like it. It's pretty easy. The more times you do this, the easier it will be and more ingrained that process will be in your brains. So I really do suggest practicing it a couple of times. We got one more for us to do together and then 2 for you to try on your own. So we're going to look at this one right now. Step 1, rewrite without the a term. Multiply a times c. Our second step, we're going to factor just like usual. I need one positive, one negative, the larger being positive. I'm thinking probably just 9 and 1. Step 3 says divide by our a term. So we'll divide by 3 and reduce. Okay, the second one won't reduce. Step 4 says just move those denominators to the front. So we get x plus 3, so that 1 doesn't really matter. And here we get 3x minus 1. That is your Berry method factoring. Now we're going to take each piece, set them equal to 0. And then we'll solve. Subtract 3. You should get negative 3 for one of your solutions. Here we'll add 1. Oops. And then we'll divide by 3. So you should get 1/3 for your second. Alright, so you've got 2 to try out on your own. If you have those Berry method instructions handy, keep those by. Use a couple of problems we've done as references. But I would pause the video right now and resume when you're ready to check your solutions. Alright, let's check them out. Your first step, you want to multiply 5 and negative 6 to get negative 30, about that a term. Your second step, we need 2 numbers that multiply to negative 30 and add to negative 7. So one positive, one negative. The larger should be negative. Let's see. How about 10 and 3? 10 and 3. Then we're going to divide by our a term and reduce. And then we'll move that denominator to the front. So let's see, 5x plus 3 and x minus 2. If you got there, you're in really good shape. If you didn't, maybe rewind and check through your work, see where you made any errors. Now we're going to take each piece, set it equal to 0, and solve. You should be getting -3/5 for one of them, and for the other you should be getting +2. We had one other one to do. Rewrite without the a term, multiply a and c. Let's see, 3 times 16, 48. Alright, two numbers that multiply to -48 and add to -22. Well, let's see, we're going to have one positive, one negative. How about if we did 24 and 2? That should give us 48 and -22. Then we're going to divide by 3, reduce, and rewrite. 3x plus 2, x minus 8 equals 0. Okay, so there is your Berry method factoring. And the final part of this problem, 3x plus 2 equals 0. Subtract 2 from both sides. Divide by 3. We get -2/3 for our first solution. And x minus 8 equals 0. We'll add 8 to both sides to get 8 for our second solution. Okay, Berry method factoring. I like it. It's pretty easy. Again, I've done it a whole bunch of times, which is why I have it down pat in my memory. You're going to have to do it a lot too if you want it to be memorized. If not, have those listed somewhere nearby while you do your homework, and hopefully it should help out with any factoring that shows up. We're going to look into something a little bit different in the next couple of lessons, something called complex and imaginary numbers, and then we'll get back to more factoring methods. So see you at that next video. Bye.